Good afternoon today to our next OpenE webinar. Today we are going to talk about high availability cluster storage solution for VMware. So this will be iSCSI based and this will be so-called iSCSI-Failover. So we are going also to show MPIO, so multi-path. So the session will be a bit more complicated than as usual. And we are also going to discuss possible problems with the configuration. So a very important thing is dynamic, vice versa, static iSCSI discovery in ESXi. Also, we will show how to configure MPIO multipath in ESXi. This is very simple actually. But tuning is maybe important if you want to have the maximum bandwidth performance, then you will need to change some default settings in ESXi. And in order to prove that it works, we will show Windows 2008 virtual machine with the running with the IOmeter, and we will measure the performance. Also, as news for today, a small surprise, I have one RAID array based on SSDs, so we'll be able to also to show you live how good SSDs can be, especially in random performance. We have written already a blog, we have posted a blog article about the how good SSDs are in random, and because SSD are becoming more and more popular, more and more reliable and bigger capacity, so this is already a very interesting solution. Let us, I will switch now to my second machine. Okay, so please use the chat window. If you will have some questions, I will stop from time to time and try to answer. Okay, so I have prepared two systems today in order to show the iSCSI failover configuration, and I have prepared, of course, ESXi server, and that's the server. Okay, and that's the configuration. I will show, I will go step by step, and also I'm going to show you where to find the material about the iSCSI failover. Okay, in order to find the material about iSCSI failover, the best idea is just to go to our website. Okay. So on our website, in the library section on the how to resources, you will find some documents. It is still under OpenE replications and also under others. For example, under other, we have how to configure DSS MPIO with Windows 2008 server. Okay, if you want quick explanation, that's very good document. Then how to configure MPIO with ESXi. So here we show only with the two paths. Yeah, so this presentation is very simple, and this presentation focuses on explaining how to configure and how to tune. This is good because there is not plenty difficult configurations here. Okay, so few pages later on we have the tuning described. We will use exactly this tuning today. Okay, so let us go back to the to how to resources sessions, and under OpenE replications you can use the OpenE DSS V6 synchronous volume replication with failover over LAN and the unicast. Please do not use broadcast anymore. we strongly recommend to use unicast. There is a few more steps to configure. You need to enter more IP addresses, but it is much more stable. So please download this configuration chart, and you can also configure as it was here. Probably the configuration was made without MPIO, but with bonding. Okay, let us change. Okay, you see here there is a configuration made with bonding, and then we have only one virtual IP address. In our case today, we are going to show with multipath, means we will have no bonding, and then we have one port with virtual IP address, and next storage port also with virtual IP address. Let us go to now. Let us switch to our blog. Okay, so where is the blog? Just click on the blog. Okay, if you want to go to blog, just write blog.openi.com, or in our website, go to community, and then you have blog, and then also we have the B icon for the blog available here. So blog is good because there are some ideas or some interesting posts about storage news. And for example, when we talk about iSCSI-Failover, or we talk about how to configure this, then there will be few questions how to configure, let's say, ping nodes. Always we see that there is a problem. People don't know or don't understand how the ping nodes works, and what for they are good, and how to configure to not make mistake. So let me find the article about the ping nodes. So let me see, when I go to iSCSI or IOmeter, high availability, probably. Okay, that's not this one. Okay. Probably it will be easier for me to scroll the articles. Okay. Okay. Older post. Oh, ping node explained. Very good. So I wonder which bonding failover ping node. There is a ping node, and I didn't find it. Okay. Good. But what is important here? Important is to read this article, and very important is to have a look on the charts. So the first chart is with the bonding, and the second chart is with MPIO. So when I click on the chart, that the chart shows actually almost the exactly same configuration which I'm going to show today. So we have of course, 2 DSS server, right? And then every server has 4 ports, right? First port is in subnet 0, so 192.168.0.230. Second port is in subnet 1, and the next port is subnet 2, and then the next port is subnet 3. In subnet 3, starting from the end, we are replicating, and you see there is a direct point-to-point connection. Okay, so we are replicating over the last port here, and we do not, optionally we can put the path over the switch, but putting a path direct is better, because then you are switch not dependent on the switch. So there is a much better reliability that this connection is live, is working between these two servers. And in today's presentation, I'm going to use this path also for the cluster configuration. So this unicast configuration will be also working over the last port. In our chart, we say that this is management port, the first one, and then also for the auxiliary connection for the heartbeat. We will not use it in our today presentation. We will show this a bit different. But this chart also showing proper configuration. As you see, here we shown also optionally more ping nodes. This article is about ping nodes, so we focus on the ping nodes here, but normally you should use 2 ping nodes as a minimum. That's the most reliable configuration. Of course, you can run with 1 ping node, but you can have even more than 2. You can have 3 or 4 ping nodes. But don't exaggerate. In the most recommended is just a 2. Okay, so and here is our storage client. In our case, storage client will have IP addresses 192.168.10.20, and in my case it will be 7, but here we just put 251. Okay, it is not really important, and we see that on the one adapter we are using one virtual IP, and on the next we are using next virtual IP. Okay, and this is the case which we also will configure in our demo today. Okay, so switching back to our servers. Let me log on to 230 and the next one 240. Okay. Oh, this is not configured yet. It's configured. Okay. Good. There is very practical information here. You see DSS 230 and DSS 240 on the top. This is exactly the server name. So please do not forget to put the server names first. So it will be very easy to identify the first one and the second server, right? So as you see, as I mentioned, we have 4 Ethernet ports for everyone, and then ETH0, so the very first adapter is in subnet 0. Okay, we are on the second one. Okay, and the very last adapter ETH3 is exactly in subnet 3. So this will be very easy for us to follow up the configuration. Okay, I have prepared the configuration already. So we are going to start to show you ready configuration, and afterwards we will delete the volumes, and then we will go step to configure this back. Okay, you see I have a primary active. The ping nodes which I have configured is 192.168.1.7 and 192.168.2.7. Okay, and let me click on the failover configuration for the Ethernet ports. I mentioned that ETH1 and ETH2 are the storage adapters, and we will have the virtual IP over there. Okay, so on ETH1 we have the virtual IP 192.168.10.250. Okay, and on the next adapter we have 192.168.20.250. Of course, both servers, so on the 230, so the first or the primary server, we have these virtual IP addresses, and on the secondary server, the virtual IP addresses, the configuration is exactly the same. 192.168.10.250 on the ETH1, and ETH2 is 20.250. Okay, and of course there are some next configuration which we need for the heartbeat, and on the ETH3 we also have the auxiliary connection configured. Okay. So in such case, when I'm on a second server, so on the 240, the ETH3 is in subnet 3, so I'm entering here IP address of the port which is on the primary server. So in this case 3230. Okay. So failover is already configured, up and running, and the ping nodes are in subnet 2 and in subnet 1. So you see the physical IP address is in subnet 1 for the ETH1, and the physical IP address for the ETH2 is in subnet 2. So over this ETH1 and ETH2 we have the storage access. Okay, so we don't care about ETH0 and 3. We only care about these ports over which we reach the cluster, because ping node is helping us, helping the cluster manager to know that the storage is reachable by the clients. This is why it is pinging over physical IP address on the card over which we access the storage. So when I will remove the Ethernet cable from the ETH1 and from the ETH2, after removing these two cables, no one can access the storage. So actually we must execute failover, and ping node will help us to take decision about executing the failover in this case. So again, if you will have some doubts, please go and read this article, and let me check, because there are some questions already. The first question is, can I use two connections for the iSCSI replication? Actually, the proper definition of the bonding is that this is a solution between server and the switch, and it is not really solution between the server and the server, but as a port failover it works, and we didn't find any problems. So you can have the bonding defined on this point-to-point connection between the two servers, but it will not work as a bandwidth gain. So we will not have the dual performance of the dual port used here. The traffic will always at the time will always go over one port. When you use round robin, it will maybe switch, but it will not send at the same time two packets. So you will not have the performance improvements, but you will have the port failover. That's true. In any installation, when you want, let's say, 400 megabytes per second, because you have 4 ports for the storage access, and on every port maybe you reach 100 megabytes per second. So the only way to solve this problem is 10 gigabit Ethernet. And the 10 gigabit Ethernet works perfect today. The cards are already very stable, and the replication speeds are something like 500 megabytes per second, or in some cases even 700 megabytes per second. So this is a really very good solution. Next question. Does the direct connection need to be crossover cable? So the crossover cable is kind of an old story, because the crossover cable was have to be used when you have the fast Ethernet. With gigabit Ethernet, there is cross coming automatically, so you just need just a regular patch cable when you are using a gigabit Ethernet port. So you don't need to care about what kind of cable you need to use. This was also for the 10 Ethernet and the 100, so fast Ethernet, but not for the gigabit. So that's good news. You don't need to care about it. Okay, and actually we strongly recommend not to use fast Ethernet. So when you have the switch, which is just fast Ethernet, so 100 megabit per second, please do not use it for storage. It must be gigabit Ethernet. Anyway, gigabit Ethernet is already very cheap today. Good, so that's the configuration, and for sure I want to show how we have configured these two. Okay, we have these two targets which are exported over these virtual IP addresses. How it is showing in ESXi. Okay, so let us go to ESXi. In ESXi we have two ports which will be responsible to access the storage. That's the NIC number 2 and that's the NIC number 3. And you see I have configured IP address for this VM kernel port for the iSCSI, and that's in the first on the first port I have configured 192.168.10 because my virtual IP is 10.250, so 10.7 in order to access the 10.250. Okay, and the second path I have configured over the next NIC, and this is 27, so 192.168.27. And over these two ports we will access the storage. But because I need also ping nodes, the best will be if I will have any option to have the ping nodes on the VMware server. So maybe if you will configure the cluster with VMware, you will have one host and then you will have a second host. So on the first host you can configure the ping node on the on this adapter which is in subnet 10, and on the and that will be only one ping node, and on the second ESXi host you will configure the ping node on the second adapter. So you see I have just one more VM kernel port configured over in this switch. In both switches I have configured these next VM kernel ports, and I'm using this just for ping node. Okay. Of course, you can use different devices for the ping nodes, but make sure that this is stable, because if the ping nodes will be missing or switching off, then the cluster will just make a failover. So nothing really important. It is not really very big problem, but you don't need, you will have the often failovers, and later on you need to go there and make sync and failback and so on. So you have extra work. When the ping nodes are missing after failover, so this is just ignored. Good. So that's our configuration, and let us also show how it is done in the software adapters. So in the software adapters, when I go to properties, I do not have the dynamic discovery. I just have a static discovery. Why? In our SCSI Target 2 software, we export the targets over every available port in the storage system. So when you have plenty of Ethernet ports, and plenty of targets, then you will see a lot of exports here. So this first, it makes mess that it is difficult to find out your proper target, and the second problem is that the scanning takes longer. So any refreshing or rescanning takes longer, because the VMware will be busy with the list, which consists maybe not from 5 or 6 targets, but maybe 30. And of course it takes longer. I will show soon, when we will stop the configuration and delete the configuration, we will show soon how to configure this as well. So important, we recommend static discovery and not dynamic, because the dynamic will show all the possible exports here. Okay. And when you enter the dynamic discovery, you just need to enter the iSCSI, the IP address. If you enter static discovery, you need to enter IP address and the target name. So you need to enter more. But from time to time, we were showing that you can enter dynamic discovery and later on remove unneeded path and then remove dynamic discovery. But unfortunately, VMware is not happy with this, because after reboot it will remove all this static discovery, because it was as a source as a dynamic. This is why you need to enter this really using this add button in static discovery. I see the next question. Let me check it. What about jumbo frames? Okay, jumbo frames we support. So if you configure the jumbo frames, you need to know that your storage ports, your switch, and your VMware must be configured for jumbo. If one of them on the path is missing, then Ethernet will use a regular 1500 MTU. And the jumbo may help you a little, but it is not a really big difference. So you may expect some improvement, especially when you work with the big files, so like backups, video, or this kind of stuff. But it is not a really spectacular difference. So when you are just running regular settings, you don't need jumbo frames. Okay, so that's the logical units which we have configured. I have right now 3 units. The first and the second are just regular disks, and the third one is my SSD. On every one, when you click on here, when you click on path, that's all the targets. When you click on devices, that it shows the logical units. So when we right mouse click, then we have option to manage paths. And you see, when in manage path, when you just go first time, you will see the fixed fixed paths, so you will need to change to round robin and click on the change button. Clicking on the change will make sure that really change to round robin. Round robin means both paths will be used at the same time, and one packet will be or one or more packets will be sent on the left, and next batch will be sent on the next one. I say batch because by default it probably sends 1,000 packets on the first card and the next 1,000 on the second, and so on, or reaching certain number of bytes. Also it is switching. So let me show also the console. You need to connect to the console. So we have I'm using the PATI. Okay, I'm using the PATI here, so you just download PATI from pati.nl. okay, so this kind of session. This is a so-called SSH session. By default it is disabled, so you need to go to VMware console and enable the session. If you don't know how to enable the session, just go to Google and look for the explanation. Let's say enable. Okay, so you will find some information or even screenshots showing how to enable the sessions. You will have to go to the menu on the console, and then you will enable the technical support, because this is actually meant for technical support. Okay, so once we have enabled, then we log in as a root. We enter our password, and let us list the configuration. So here there is a command which is called ESXi CLI. When we just enter ESXi CLI, then we need to enter the next parameter. So the next parameter is, in our case, NMP, okay, because we want to check the multipath settings. When I enter NMP, okay, the next parameter will be device. Okay, we are looking for this one. Okay, so let us enter device. Okay, and now we are going to have a look what's going on the settings. So the next will be list. So you don't need to really remember. If you just enter with missing, it is showing you what is missing. So list, and now it is listing us. I will make it big. Okay, it is listing us all the multipath devices, and we see that the currently, okay, the settings are like this. Okay, the policy is IOPS, and IOPS is 10, and the bytes is 64K. So this is not the default setting. Before you do any tuning, you will see that this IOPS is when you enable multipath, it will be maybe 1,000 or this kind of, or these bytes will be also a bigger value. Means the switching between first and second path will be not so frequent, and we need a bit more frequent settings as we have here. So how to change these settings? You can enter these settings just from the command line every time, but we want that after reboot the system will have the settings. So here we have such a such a small program, bash script, which is running every reboot, and the bash script is just etc rc.local. Okay, so when I was showing the script, I was preparing already a very small while loop, which is entering these values for us. Okay, okay, so that's the script which is changing the policy to IOPS, and then it's changing bytes to 64K, and it's changing IOPS for 10 for everyone. For everyone which is starting with EUI, okay, because all these which are starting with EUI are just SCSI devices. Okay, so we will want to switch these to 10, maybe to 100. Let us see. So when I run this rc.local, I will change the values. How to edit this file? Okay, if I want to edit, instead of cut, which is just typing on the screen, I just go to VI editor, and the VI editor on ESXi there is only VI, on ESX there is also Nano. It's much easier to use. ESXi is a very user unfriendly editor. It is not like you go and edit. You need to enter a command if you want to edit. So now I cannot do anything. I need to enter command. Let's say I want to insert characters or remove characters. So I enter I for insert. Okay, so I'm typing now I for insert, and I'm already now in the insert mode. So let's say this IOPS is going to be 100. So I enter 0. So you see it is adding the 0. Okay, and now I'm in insert mode. Now I want to save the changes, so I need to go to command mode. So I'm entering the escape key. Okay, and now you see, maybe you see there is no I here. And then after entering escape key, I'm in the command mode, and now I can enter my command. But the command must start with the semicolon. So I put semicolon, so colon, colon, dot. Semicolon is dot comma. So we just put the dot, right? So colon. Colon, and W is for write, and the Q is for quit. Okay, so when I enter this, as you see, I'm coming back to my bash prompt, and when I cut it, then you see I have changing this to 100 in my script. So let us now update the changes. So I will just run the script. So etc, that's the path, and rc.l, and when I click on tab, I will just complete the commands. I don't need to write the full command. So the tab key on the keyboard is very big friend of us here. Okay, when I enter, so now the rc.local script was executed, and when I will see what's going on with the parameters, so now I'm using the arrow key and to browse through the commands I have entered before, and you see what happened on my EUI devices. I have these IOPS 100. Okay, so the script was updating all these. Okay, and there is here one more. Was updating the settings. Okay. How it works, I want to show you a virtual machine which is running on the SSD. So this disk, the last disk, is a SSD disk which is right now connected over the physical connection. And so it is so far it is just connected to my first machine, but it is very good to show the performance because the SSD is very quick device. So we will be observing nice results. Okay, let us start this virtual machine. So the machine is, you see, this machine is running on this data store. Okay, and I will power on. Okay, when I power on the machine, which is saved on our SSD iSCSI disk, that's the Windows 2008 R2 64-bit virtual machine. Okay, the machine is starting and is started. As we see, the starting was also quite fast. Then let us log in to the console. That will be much more. Okay. Okay. Okay, I have a console here on this computer. So when I sorry about it. I need one more. Okay. Remote desktop connection 192.168.0, and I gave address 70 to my machine. Okay, administrator. Okay. Okay, good. So now we are running this virtual machine desktop, and also I was copying already IOmeter here. And when I'm starting IOmeter, then you see I have a drive C, and the drive C is available for test at once. Okay, how I made it? Because normally when you start IOmeter on the formatted disk, you will see the red line here, which is just making it impossible to test until it will create such a so-called test file. But again, good that we have our blog. Okay, let us go to our blog. And this time will be easier, just IOmeter on the tags, and a few practical tips about IOmeter. Okay, and here we have a nice surprise for you. You can free download the so-called test file creator. Test file creator is a very small program which is creating any size of the test file you want. So you can create, let's say, 1 giga file, you can create a 1000 giga file, or you can create a 10 terabyte file within a second. And by default, this test file creator, it is creating file on the root on the drive C, and exactly the name which IOmeter is. So okay, so I will show you after I downloaded the okay, when I download the file, I have it in the I have the file. Aha, sorry, I'm not. This is on the virtual machine. Okay, let us go to our virtual machine, and our virtual machine. Okay, administrator CD. Okay, you see there is the test file here. When I run the test file, the usage is test file, and the size in the kilobyte, megabyte, gigabyte, or terabyte, and the file name. When I do not put the file name, it will just put the CIOBWTST. So exactly the file which I need for the IOmeter. And as you see, when I switch to see, that's exactly the IOmeter file is created on the that's exactly the one which is 5 giga, okay, created here. So when I delete this file, so delete IO, okay, when I delete this file and when I start IOmeter one more time, that's the problem. I cannot start the test at once, otherwise IOmeter will take long time to make full the disk with the test file. So okay, let us users administrator downloads test file, and let's say I want 5 gig. Okay, I enter, and I have already test file created. So that's a very nice toy when you want to play with IOmeter. Okay, so you see now IOmeter is happy. Let us start. Click one more worker. So now we have 2 workers. On the first worker, I select the drive C for testing. Second worker, I'm select for testing. On the both, I put 10 outstanding IO. Okay, okay, and now I select the computer, and in this case the next settings will be already done for the both workers. So don't stay on the worker, because if you are on the worker, then the next settings will be done only for this particular worker. When you click on the computer, the settings now will be done for both workers. Okay, so now let's say we want to start 32K 0 read means 100% write, okay, and 0 random means 100% sequential. So let us start this kind of test. So we have some value 50K, okay, 57 megabyte per second. Okay, maybe we are happy, we are unhappy, doesn't really matter. When we create a new one, and then let's say want to show option for the bigger performance, mostly with 64K you can already saturate the connections. So let us start with 64K. Okay, let us say we want sequential, and let us say we want random write, sequential write. So 64K sequential write. Okay, very good. So we have such pattern. When we add, then we add this to both workers, and when we start the testing. Okay, we have something like 120 megabytes per second, 110, or even below 100. So it is the test is working, but actually it is not what we are expecting, because we have multipath, and then we would like to see something like 200 megabytes per second. So how to do it? Again, we go to ESX, and now that it's time for tuning. So when I go to ESX and to the console of my ESX, and now I edit my starting script, and then I want to edit. So again, in order to edit, I need to enter I for insert, and you see the I shows, and I'm in insert mode. So let us reduce these 100, let's say, to 10. Okay, now I want to save it, so I click escape in order to go to the command mode. You see now I'm in command mode. Then I enter the command starting with the colon, so the dot colon, and W for write and the Q for quit. Okay, let me prove whether it's really works. So when I cut it, see, yes, exactly, it's 10. Okay, so that's the change. So now we want to post the change. So I need to run the rc.local. So I'm running, and then let us prove the changes. I need to list the devices. Okay, so now you see IOPS is a 10 on these UEI devices. And let us check what's going on with performance right now. Okay, so when I switch to the remote server, and when I start the you see, before we were having something like 70. When I start the IOmeter right now, so we see the difference at once. Okay, so now we are reaching nice number, 200 megabytes per second, because we are running on the two cards. So let me switch to okay, I see some questions already. Okay, the next question was also 4 gigabyte jumbo frames in IPv6. Whoa, I must say I didn't check the 4 gigabit jumbo frames in IPv6 yet. It is something new for me, and I will be probably happy to hear from you if you have some good experience here. All the tests we make are just on the IPv4, so we didn't test yet the new IP protocol. But nice to hear that that you have already some experience. Again, I will be very happy to hear you about the possible results here. Next question. I have set my IOPS to 100 based, and another article from OpenE should use 10. Oh, this depends on your applications, because if you really want to have the maximum bandwidth, and if you want to go to 200 megabytes per second, you will not reach it with 100. So I was even switching to 1. So every packet was changing to different path. But this 164K was kind of compromise, and it was tested with some applications, and not with IOmeter, and these applications were running most efficient on this kind of settings. But again, this depends really on what kind of applications you have, and you can just change the settings and measure how the application runs. We are not going to show you here the best settings, because again, it's not possible. It is application depending. Next one. Do you need to turn off your VMs before editing the IOPS? No, actually not. You can change this IOPS dynamically, and then you will see the difference at once. Okay, so now we are done with the testing, and maybe it will be interesting to also to show the different pattern, because when we have the SSDs, then it will take maybe 1 minute. Let me create the pattern, which is you know, the regular pattern, 2K, 100% random, 33% write, and the rest is reading. So 67% for reading, 30% for writing. That's the default pattern of IOmeter. Let us see how does it work. So when I start this one, okay, so you see on such a 100% random pattern, we are getting yeah, quite good results. Okay, it is 16,000 IO per second. Yeah, with 100% random pattern. So that's actually a very good result. And you need to really pay you need to pay a lot of money. The price is very expensive if you want to see such a number of IO with the 100% random. Let's say 4K, 100% random, and the same pattern. Okay, I need to remove it. Edit 4. Okay, it's 4. Edit and test. Okay. So you see, we are reaching 60 megabytes per second and 15,000 IO per second in 100% random environment. Okay, that's proof that SSD disks are really working very well. Okay, that's enough for benchmarking and for tuning. And we are ready. So now I can already stop this virtual machine. Let me shut it down. Okay. And let us come back to our ESX, and I will just stop the, I will step by step remove the configuration. So first step, I can go to static discovery, and oh, maybe before I will remove the configuration, maybe it is good idea make one short test of our failover. Okay, but in order to make some small test of our failover, we will need to run at least one of the machine which is stored on the failover disk. So here, this one not, this one not, and oh, I have deleted the machine which was running on the, okay, the Windows is probably too big to copy this fast, so maybe I will copy the Ubuntu. Okay, so let us go to storage, and yeah, HA cluster is empty, and this one is empty as well. So I will go to my local data store, and I can copy the Linux machine, and I can paste it. By meantime, I will still continue explaining the configuration. So the very first step was creating the volume group and creating logical volumes. In my system, there is a one RAID array, hardware RAID array, and the second, that was this SSD. Okay, so on the hardware RAID array, on the first hardware RAID array, I was creating the 500 and the 501 gigabyte iSCSI volumes. The volumes are block IO volumes. It is good practice to have the volumes, even they are going to be the same size. When you create them with 500, 501, it will be easier to recognize them. So don't necessarily put all the volume exactly on 500 gig. When you put even very small difference, it will be easier to recognize which one is one. Okay, the next point is when I have created the block IO volumes, then I need to create the replication. So the replication task. When I start with replication task, I need to put the IP address of my cluster server. So when I am on the first one, 230, then you see I'm putting 240, and the same thing is on the second one. Okay, here I was putting the 230 in the subnet 3, but because the subnet 3 is our replication port. Okay, and on the secondary server, my volumes are marked for destination, and on the primary server, my volumes are marked for source, because the volume replication algorithm works in so-called active-passive, and only source is exported, and the destination is working like kind of slave, which is just available for the source in order to replicate the data. So the destination disk is not exported at all. If you are curious and you want to check whether your data are really existing on the destination, you can create a snapshot for this volume. You can start the snapshot and export over the new target, and then you can mount this, log on to this target, and then you can have a look whether your data is there. So over a snapshot, it is possible to have a look inside the destination volume. Okay, let me stop because I see a question. The next one, what about normal disks instead of SSDs? Oh, if I will run the the 64K block performance on the normal disk, I will have exactly the same result, because on the sequential part, the SATA disks or SAS SATA disks are very good. SSD disks are a bit better, but it is not so spectacular difference. But if I run the 2K block on SATA RAID array, exactly like here, maybe 4 or 5 disks, instead of 16,000, I will see only few hundred. So the difference on the random can be 10, 20, 30, 100 times more better on SSD than on the regular mechanical disk. This is because the SATA disk has a seek time on the random access. So when you on sequential from one sector to next sector, which is in the next cycle, you need to spend, so the heat it need to spend maybe 0.1 millisecond or maybe 0.2, I don't know exactly, but below, much below 1 millisecond. And when you move from the sector to another sector, which is totally different place on the disk, you can spend maybe 10, 15, 20 milliseconds. Okay? In case of SSD, this seek doesn't exist, because it doesn't matter if you need the next sector or the last sector. This is made on the addressing, and access time here is identical. So this is why the SSD disks are so good on the random performance. But the random performance is very, very often very important in the regular applications. Sequential, it is typical for the backup, or video streaming, video editing, this kind of applications. But please note that when you backup many workstations, or when you video editing from many workstations, this is no more sequential, because from one it is sequential, but when you mix more of them, then some of them will use one part of disk, another will use another part of disk, and in this case RAID array starts to work in mixed mode, a bit sequential, a bit random, and it is becoming slower and slower. So this is why if you have this kind of application that say 20 workstations, it is video editing, it is already no more sequential, it is just a regular random access. Okay, next question: what will be better in performance, use iSCSI volumes with failover of NFS export over failover? Depends. I will say that the iSCSI probably is very comparable, but I was in some, the sequential maximum speed, we were getting a better result with iSCSI, but not necessarily with random. But NFS has some more options which are not available with iSCSI, because iSCSI are just disks, and the NFS is a file system or network file system. So I can have the NFS failover, and on top, additionally, I have access with rsync, so I can, in asynchronous way, I can replicate the data which are on NFS failover to another location. So this is sometimes very, very wanted feature. This is why NFS in such cases is a solution. Okay, but if you just need a regular high availability cluster and then you don't need to replicate to colocation, then iSCSI failover is the first choice. Okay, good. So now we have shown the replication. The next one is exporting targets over the iSCSI. So LUNs over iSCSI targets, and let me show the primary first. Okay, here I have still 3 targets because I was having this SSD as well. On the target 0, you see now I'm using a SCSI ID, which is a random ID. When I create a new logical unit, or every time I click on the minus and plus to connect a logical unit with the target, the system is generating a random SCSI ID. The random SCSI ID is always works well, but sometimes in some presentations we were showing, let's say SCSI ID of the first one is 0, next one is 0001, or this kind of stuff. If you put 0 and all 1 or 2, then no problem. But if you put too many 0 and most of the LUNs are almost identical, VMware will have a problem. And it can be that you have 3 targets and you will see only one logical unit, one device. So you will go here to the storage adapters, and you will see maybe 6 targets in our case, and you will see one device. So when you will click on path, you will find that these numbers of all 3 targets will be identical. In our case, we have, in pair identical, because this is a multipath. Okay, but the best practice will be when you are configuring the iSCSI IDs, just allow system to generate the random number, then copy this number and paste on the secondary. So you see, in my case, this starting with the GH and then finishing with R, and here is exactly the same. The number was copy-paste. On the second volume, on the second target, it is the same story. I'm starting with V, finishing with HF, and you see here, when I click on the second target, so target 1 in my case, it's exactly the same SCSI ID. If you will forget to put the proper, copy-paste SCSI ID, while you starting the cluster, it will prompt you to fix it. It will not start the target iSCSI-Failover when the numbers are wrong. So let us check whether the copy is done. So copy is done by meantime. So we can add to inventory our Linux machine. So that's, I will just put that this is a iSCSI high availability. Okay. So we have the one virtual machine which is placed on our iSCSI disk, and let us boot the power on the machine. Okay. So while we start the machine, we will just make some failover test. Okay, so let us wait a few seconds until the server is started. I am not sure. Okay, the machine is starting. Okay, then let us maybe Okay, the machine is started. We can see whether it works. Okay, then let us do one more thing, because this can be very important, that you make sure that everything works properly. So we can go to storage and can copy a virtual machine, let's say the big one, and we can copy this to the second. The Windows machine is a bit bigger. It's probably over 40 gigabyte, so it will take a longer time to copy the machine. And by meantime, we can already, okay, we're still here. We can try with the failover. So I go to setup failover. Okay. Okay, that's the secondary, and then we go to the primary. Okay, primary is properly active, and then we can click on the manual failover. Okay. So now we are switching activity from the primary system to the secondary system. The primary, after switching activity to the secondary, become suspend, and the secondary become secondary active. Okay, so activity is moved to the second system. Okay, so the cluster is in the gridded mode because we have no more redundancy, no more way to fail over to another server, because it's just two servers in the cluster. The connection between or both servers now is failed, because the connection, the primary enter suspend mode. It is not trying to communicate. And now the next step, if we want to move activity back, then we will need to run a synchronization. So now we see that the virtual machine is just copying, so doing the failover on the second high availability iSCSI volume didn't interrupt the copy process. And of course our server here is up and running. There is no problem at all. And the most critical is copying, of course, right? This is really creating IOs and heavy duty IOs during copying. So now let us synchronize. So I click on sync. That's the first step in order to move activity back to the primary server. And when we move here to the reverse tasks, we'll see that they are still stopped, but after a while they will see that the tasks are started, and then the tasks are just starting, and then when the tasks are running, then we will see whether there is something to replicate, right? So in our case, luckily there is something to replicate on the second volume, and there is nothing to replicate on the first volume, okay? Because we are copying the machine to the second volume, and it is copying quite fast. So during the new data is coming, we are still replicating old and new data. Okay, the replication speed limit was set to something like 60 megabytes per second because I have two logical volumes, and my replication bandwidth is gigabit Ethernet, so something about 120 megabytes per second. In such case, when you set the tasks, please get the bandwidth and divide by 2. If you will have the, let's say, 5 tasks, then you will divide 120 by 5. Okay, so now the replication is done, so we are consistent, and then we can click on failback in order to move activity back to the primary server. And you see we are copying all the time, and now we are moving activity back to the primary server. Also, when we just have a look on our virtual machine, when I focus on the okay, oh sorry, so the copying and the machine is passive already, and the primary, when we switch to setup and the failover, the primary is just active, and then one more time secondary is passive. Okay, so everything works well. We are copying, and our virtual machine is working without any interruption. Okay, so there is no I/O, nobody noticed about the problem. The same thing is when I just let's say shut down the first machine. Okay, I can just go and shut down the first machine, and I will power off the first machine. It will transparently to the user switching to the failover, to the second machine. So because we are running already out of time, we were planning something like 1 hour and 15 minutes. Let us see whether we have more questions. Okay, so far I don't see more questions. I would like to remind you that if you will want to see the presentation one more time, then just email to us. Otherwise, wait, maybe in 2 weeks it will be on our website, and tomorrow will be on our FTP server. And don't forget about the presentations which are on our how-to resources, and then you can just follow step by step to configure the unicast. Don't use broadcast, use unicast configuration.